All right, so let's check this question. So this question is on electricity, all right, resistors to be specific. So the question says 3 resistors with substances 250 ohms, 500 ohms, and 1 kilo ohms, that is 1000 ohms, are connected in series. A 6-volt battery is connected to either end of the combination. Calculate the potential difference between the end of the 250 ohm resistor. So let us represent this using the diagram. So series, the first one is 250, 500, and 1000. Connected to a 6-volt battery. So this is the diagrammatic representation of the whole circuit, all right? So now, the first thing that we are going to do here is to calculate the effective resistance of this circuit. So the effective resistance is going to be R1 plus R2 plus R3, which is going to be 250 plus 500 plus 1000. That is going to be 1750 ohms. Okay, so the effective resistance or the equivalent resistance of the whole circuit now is 1750 ohms. All right, that one is sorted. Let us proceed to solving the question now. It says calculate the potential difference between the end of the 250 ohms resistor alone. So we need the potential difference across this guy alone, this 250 ohm resistor here. That is what we need. To get that now, the first thing that we need to establish is that this is a series connection, right? So what are the things that will happen in a series connection? In a series connection, you should know that the same currents will pass through all the resistors, but different potential difference will pass through each of the resistors. Let me take that again. The same current will flow across the resistors, but different potential difference will flow across them. So in a series connection, the same same current and different potential difference. But in a parallel connection now, different currents, same potential difference. So in a parallel connection now, you have different currents passing through the circuits, but then you have the same potential difference across all the resistors. Okay, so in a series connection, the same current, different PD. In a parallel connection, different current, same PD. Now this is what we are going to use to solve the question. So the question asked us to find the potential drop across the 250 ohms resistor, Abi. So now we already know that the same current will pass through all of these guys. So we need to find the current across them. That's the next thing we are going to do. So to find the current across them now, what are we going to use? So to find the current across them now, what are we going to use? V is equal to IR. All right. So this is going to be the V total and R total. So our equivalent I is going to be what? Your V is 6 over 1750. So my equivalent current or my total current across the circuit now is 0.00343 ampere. All right. 0.00343 ampere. That is the total current that is passing through all the resistors equally. Okay, now to now find the potential difference across this 250 ohm resistor specifically is going to be my total I times my 250 ohm resistor specifically too. Okay, so my V is going to be what? 0.00343 multiplied by 250, and that is going to give me 0.86 volts, and that is option B. So that makes option B the correct answer. All right, the correct answer. Now to verify our answer now, if we calculate the potential drop across the 500 and across the 1000 ohm resistor and add it to the potential drop across the 250 ohm resistor, everything must be equal to 6 volts. All right, if you calculate the potential drop across the 500 and the 1000, then we add it to the one that we calculated for the 250 ohm, it must equate to 6 volts. All right, so let us verify that now. Okay, now so let's calculate the potential drop across the 500. We already have the 250 as 0.86 volts. Don't forget that. So across the 500 now, so it's going to be V is equal to 0.00343 multiplied by 500, that is going to give me 1.72 volts. So the V across the 1000 is going to be 343 multiplied by 1000, and that is going to be 3.43 volts. So if I add everything together, 0.86 plus 1.72 plus 3.43, everything is going to give me 6.01, which is approximately 6 volts. All right, so that corroborates our answer. That means that 0.86 volts is very, very correct. So do we get? So that is the explanation and the answer to the question. Thank you.